Hey everybody, what's good? What's going on? JB here, back with part 2 of my walkthrough of my build out of my initial CI/CD pipeline. If you remember, a week or so ago, I put out a video talking about going through and building out a continuous integration, continuous deployment pipeline for network automation. And I was using a blog post, or series of blog posts made by my friend JulioPDX, to kind of walk through the integration of a whole bunch of different technologies, including GitHub, Docker, Python, Nornir, NAPALM, a whole bunch of different tool sets all coming together, all coalescing into some sweet CI/CD pipeline goodness. So today is going to be part 2. We're going to pick up where we left off, and yeah, let's just go jump into it. As always, when I say all this good stuff, make sure you smash the like button, subscribe to the channel, all that goodness that comes along with being on YouTube, and I appreciate everybody who's dropping in to check this out. So let's do a quick recap of what we had going on here. So this was a diagram that Julio had that kind of broke down and gave a high-level view of all the different components of what this system actually comprises of. And so we have ourselves and whatever configurations that we want to use and push out. And then we have GitHub, which is kind of our central source control for all of our different configs and Python scripts and YAML configs. And this is going to be where we're housing and making all of our changes. Or you could be doing this locally on your own Git system on your computer or server and pushing it up to GitHub. Then we have ngrok, which is kind of, I don't want to say it's a proxy, but it's sitting in between GitHub and then the drone servers that are on your private network. So ngrok ends up giving you the ability to have a public IP address, which allows for the webhooks that are necessary between GitHub and the servers that are actually controlling our CI/CD pipeline, which is our drone servers. So the drone server sits there, and there's a drone server and drone runners. Drone servers is what actually interacts with GitHub and pulls down the necessary files. And then these drone runners are actually the servers that end up doing the actual jobs that are necessary to complete whatever the actions are, or to build out the containers that are necessary to do the actions required for our CI/CD pipeline. So throughout the video, or the first part that we did a week or so ago, what we really did was we set up the repo in GitHub, we downloaded and installed ngrok, we downloaded Docker, and then did the configurations for the drone server and the drone runners. And then we made sure that all of this configuration, or all the configurations, were necessary in place to have the communication between all of these. So if you remember the public IP address we got from ngrok, we had to create an OAuth application on GitHub. And then we also had to take that information and some key information from GitHub and put that into the drone server, drone runners configurations. So at that point, that was where we left the walkthrough as of last week. Part 2 today, we're actually going to jump into building out the YAML configuration file, which actually lists out all of the different steps that we need to do in our CI/CD pipeline. Remember when we looked at this last week, trying to see if we go to my GitHub, kind of looked at all of this and I was like, this is quite a bit of stuff and it is overwhelming. Well, really at this point in the process, we don't have anything up here yet. So don't feel overwhelmed by that. We're going to walk through this in an iterative fashion to get to the point where everything there that needs to be there will be there. So really we're going to be starting with this initial drone YAML file, or you can name it whatever you want. I just named it .initialdrone.yml. And remember, whatever you end up using for your YAML config file, you need to actually have it specified in the settings within the drone server for the repo that you're pulling down. So if we go and look at that back in this drone server and we go to settings, if you remember, it's going to be all the way at the bottom, and there's our configuration file. So with that being said, let's hop over into Julio's blog real quick to kind of see what he has to say, and then we can walk through our own specific configurations to start to implement what it is that we need to do. Let's see, I don't think we're on part 4. I think we're on part 3. So let's move back to that. Okay. So he was saying, yep, at this point, we have Docker installed on our host machine, and we have the drone servers and runners. And now we're going to start focusing on the drone.yaml file. And so really, this file is necessary. It's kind of a configuration file that steps you through all the different actions that are going to take place within your pipeline. Got to make sure that you put this YAML file at the root of the directory for your project. So in this case, if we go back and look at mine, we see that within this repo, it's within the root level of the repo. So here's a very basic, this is going to be kind of the initial one that we're going to do. Lines 1 through 3 is just the highest settings of the pipeline. So what type it is, so it's pipeline. Type of pipeline, it's going to be, we're going to be using Docker. Since you're using the Docker runners, if we're using something else like exec, we could have that there. And then whatever we want to name it. The first step here, you're going to give it a name and then an image. Now the image here is going to be any type of image that Docker has and has available from Docker Hub. So in this case, we could just go with a basic Python image. There's more specific images based off of specific versions of Python, and they also have different sizes. So some are a little bit more stripped down as far as the dependencies that it has, but we're just going to go off the bat with our first go through here, just the regular Python image. And then this environment area here, this deals with us being able to have variables for usernames and passwords. If you remember back, we were looking at this in drone. In the previous video, we set up a user secret and a password secret. So we can actually have that be held within drone and pass that as a variable and any of the scripts that we're doing. That way we don't have to put usernames and passwords into scripts. And then based off of this, so it's going to spin up a Python container. And then these are going to be the commands that it's going to run. So basically, we're going to do a pip3 for Python install of these different modules. Now, the modules are going to be laid out in this requirements.txt document. I'm going to show you what that is here in a second. Then once that those modules and dependencies have been installed, then we're going to run the Python 3 command to run a Python script, which in his case, this is bat.py, but I have a different Python script that I'm going to show you. So let's actually take a look and see what my version of this is going to look like. So we're just going to hop over into PyCharm, which is where I do all of my different configurations before I push it up to GitHub. And this is going to be our initial YAML file. I mean, it's pretty straightforward. So up here is the same stuff that Julio had. This name is going to be check IP interfaces. We're going to pull down the Python image. There is the environmental variables that I set for password and user based off of the secrets that we had. And then running the same command with this requirements document. Now, if we go and look at what that requirements.txt is, it's just a whole bunch of different Python modules that would be needed to do different things. NetMiko, PI Batfish, NAPALM, Nornir. You might be familiar with some of these. NetMiko's used for making SSH connections to different types of devices, where NAPALM and Nornir are used for network configurations, being able to push and pull different types of information from network devices when you're writing Python scripts. So all stuff that's going to be useful and all things that we're going to need for some of the other containers and jobs that we're going to be running later on in the pipeline. So that was the first line. The second line is this check IP.py. If we go and take a look at what that script is, this is just a very basic NetMiko script that's going to log into a network device and in essence just run a command. So if we look at what we have going on here, we have these variables that we ended up establishing for user and password, which are going to be used later on down here in this actual profile for connecting to the device. Here is where you end up putting in the actual names of what those secrets are that we put in the drone server, so user and password. And then here, I just have the device type, which is Cisco iOS. Now this ends up coming from some of the NetMiko configurations. And this script itself partly is from David Bomble's Python for Network Engineers. He had these set statically. I ended up changing this so that I could use these environmental variables, so I don't need to have the username and password in the config. Then we get down to here. It's going to make a connection using the connect handler. The output of that is going to be whatever commands I want to send it. So in this case, it's just a show IP in brief to see the IP addresses that are on a device. You can put any command that you want in here, and then it's going to print and show the output. At this point, you might be like, what network devices are you connecting to? I guess I might as well show you that as well. If we hop back over here, just in my Cisco CML lab, we're really just going to use two different devices. The switch 1 and the switch 2 are going to be what we're connecting to in this lab. Obviously, the point of these CICD pipelines is to connect to tens of devices or hundreds of devices. That doesn't really matter so much in us just working through the prototype of this pipeline. The whole purpose is being able to show the different actions that you can have within your pipeline and how efficient it can be in moving between multiple jobs. And doing it in an automated way where it doesn't require human interaction, where if we were doing this in a manual way, there would be a lot of logging in devices, moving configurations around, things like that. All right, so let's go back to this. All right, so I think that we can go ahead and kick this off. We're just going to go ahead and commit and push it up to GitHub. I'm just going to go testing with initial build out. We're going to commit and push. And this is pushing that YAML file back up. There we go. Let's go back over into our drone server and see what we have going on. Testing initial build out. You can see that it's already doing that. So this clone, it pulled down all of the files from the Git repository. And now with this check IP interfaces, if you remember what was on the that YAML config, we can just go and look at it real quick since it just got pushed here. We're going to do that install of those requirements first and then run the Python check. So you can see this is actually taking quite a bit of time because it is trying to pull down all of these different things, the different requirements to end up building out this server. Or I shouldn't say to build. So you can see it's taking quite a bit of time because it's pulling down all of these different modules to end up building out this container. Now, having done this before, this is great that we're automating things. It's pulling things down from GitHub. It's building out these containers. I will let you know that because of all of these dependencies, this is going to take a long time, which is what's going to lead into the next step that we're going to do. But we're going to sit back. We're going to let this do its thing, and then we'll come back once it's done and take a look and see what happened. All right, so it looks like we're finally at the end of this. And you can see it took about 30 minutes for this to run. And if you noticed when I first kicked this off, there was a bunch of errors at the beginning. That ended up actually timing out after about a minute, so I just ended up having to go up to the top here and hit restart. And then once I did that, it was able to pull all the stuff that it needed to. And as you can see, it kind of just goes through everything here. Took quite a bit of time. And then after it did all the installs that it needed to with all the dependencies and creating whatever types of permissions it needed within the container to be able to run what it needed to run. Then it ended up running the Python script. can see that here at the end. And then here is the output from that Python script showing the up interfaces on switch number 1. So that's great. It's automated. I could have just gone and done that manually myself, and it would have taken much less time. So what can we do to kind of help speed this up so that we don't have to go through this process every time we go to kick off something within the CI/CD pipeline? Well, Julio actually ran into the same issue with his. And in his case, it was taking about 17 minutes. So what he ended up doing and what I ended up doing was creating my own Docker container image. And so what we can do with that is actually create an image that's already there that is on our CI/CD server, that whenever we go and kick off anything in the pipeline, it's just going to use that image instead of having to actually build the image from scratch every time we do it. Now, it is worth mentioning that if you're going to do that and then push it up to Docker Hub, you do need a Docker Hub account. Really straightforward. So let's take a look at kind of the simple components that go into actually being able to create your own Docker container image. There actually is a pretty solid blog here that Julio references. But honestly, what he has here, as far as what you need to do, is perfectly fine. You can just follow that. So the first thing is you need to have a Docker file, which is going to say what version of container you want to have. So in this case, you're using the Python 3.9.7 -slim variant. I think the slim means that there's less stuff in it, so it's a little bit more, a little bit of a smaller footprint as far as what's needed. And then dependencies, again, this is just copying over the requirements.txt document and then running pip with the requirements.txt document to make sure that all the modules that you need are installed. So once you have those two files in place, then you can run these commands, docker build -t, and then whatever the name is of your Docker Hub account. So in my case, it's John Breath. It matches my GitHub. And then /, and then whatever you want the name of your container to be, space period. And then if you want to push it up to Docker Hub, then you can just use that. So if we actually can go look at my repo here, and we can just go back, and we can see I have two different Docker images up here, and you can see the amount of times they've been downloaded to run in the CI/CD pipeline. And you can see the last time that one was pulled was about an hour ago. So pretty cool, pretty straightforward. It only takes about 5 minutes to sign up for a Docker Hub account. So let's just take a look. I'll show you real quick what this looks like. I just have a directory called Docker, and then that's where I put my Docker file. You can see really straightforward, nothing too crazy there at all. And then obviously the requirements.txt, we already saw that. And then that's also up on GitHub. So then once you do all that, then you end up creating the image with the docker build command. And then if we want to actually see where that image is, remember the commands that we're running before to look at Docker images, and we can see that we have it right here. Yep. So pretty good. We have that. Now let's go actually change the configuration that is in our YAML file to actually use that new image. And then we'll see how quick it goes this time. And I think you're going to find that it's quite a bit improved. So just going to move over into PyCharm. I already have some notes here, so we can kind of just copy this over. The other thing that we're going to do is comment out this pip3 install, since we don't need to do that because of the fact that we're using an already pre-built container image. So just go like that. We can go ahead, commit that with image, then we can commit and push. Do that, and let's go see what's going on. Testing initial build out with Docker image. And there we go. So instead of it taking 30 seconds, or 30 minutes, I should say, it only took 19 seconds. So you can obviously see the vast improvement and why it would make sense for us to want to maybe build our own container images and have them ready to go to spin up in our CI/CD pipeline versus building stuff completely on the fly if that's not needed. All right, so now let's go back to Julio's blog and see what we have going on next. So throughout the rest of this, he's kind of showing some additional things that we're going to be adding to the YAML file, but I want to actually go into these one by one to show you what they are versus just jumping into this config. So we're going to actually move on to his next blog post, part 4, where we actually do a little bit more of a breakdown of stuff here. So at this point, just for recap, if we look at what we have going on in our YAML file, we just have one step, which is running the check IP Python script. It's connecting into a network device in my lab, and it's using this Docker image that we've already created. So let's step through a few other things that we can add into our pipeline. The other thing that's kind of important to mention, and it might be kind of common sense, but it's worth mentioning anyway. Your order of operations within that YAML file is important. So depending upon what it is that you're trying to do, certain tasks you might want to have done before other tasks. So just keep that in mind when you're actually figuring out what type of checks and configurations you want to do, and make sure that you build out your YAML file appropriately. So the next thing we're going to add in here is black code styling. So this is a black code format check. Which pretty much is just going to look at all of the different Python scripts that we have in the repository and use a code formatter to check to make sure that it matches the Python PEP 8 standard. So that's just a nice little bit of housekeeping. It also will let you know if there's something jacked up with your script that maybe will cause it not to run. But really, really easy, very, very straightforward. All we're going to do is, in essence, take this configuration here, obviously replace the image with whatever image you're going to use, but the rest of this is going to copy and paste it over into our YAML file, and then we can actually let that run. So Julio kind of gives some examples of just some formatting errors. So in essence, like having it written out, this list written out like that, where the correct formatting, they want to have it like this. I'm going to show you with one of my own scripts. We're just going to jack something up and we're going to see what happens. So let's move back over to PyCharm. And we can go ahead and add that into our YAML file. We want the black code format check. The other thing that is worth mentioning with this is if you do use this, and obviously you want to have some type of way to actually run a format check maybe on your scripts before you even push them up to GitHub. So depending on the IDE that you're using to build out your scripts, there are some different ways to do that. Within PyCharm, I actually ended up finding a way to integrate that as an external tool. So there's a black scanner that you can use for that formatting to do that. Just might be something that would be helpful, and you'd be able to see what happens before even having to push your stuff up to GitHub and into the CICD pipeline. So we have added this next step into our process. We can go ahead and commit that. Format check, commit and push. And let's move over and see what happens. All right, we see that this execution is kicked off within the pipeline. Pull down the configs from GitHub, doing the black code format check. Everything was fine. You also noticed that it mentioned 5 files would be left unchanged. And there we go, we were able to do that. So if this had failed, what it will do is it won't allow us to move on to the next step, which is important. So worth mentioning here, so I mentioned 5 files that would be left unchanged. If we actually go back and look at the repo for what is up on GitHub, we have 1 Python file, 2 Python, 3, 4, and 5. So it's checking all that. So it's looking at all this stuff in the repo, even though we aren't necessarily using this stuff in the repo yet, based off of what we have configured in our YAML drone config. But it's still going to look and see what's in the repo and run checks against it. Let's see if there's anything else there. I think we can go back over to PyCharm and jack up some Python and see what happens. So we can just go open up one of these. Doesn't even really matter what it is. We're just gonna throw in some garbage text. And we'll just push it up. And if we go back, and we should see the pipeline kick off. There we go. Let's see what is going on there. There we go. And it shows us that in the script, it cannot parse this line because of whatever garbage I just threw in there. And then it tells you the other 4 files are fine, but 1 would need to be reformatted. So pretty straightforward, pretty easy, but a nice little check to have for your Python scripts before it actually starts doing any real work in the pipeline. Well, let's see, we can get rid of that. And we'll just push that back up. We'll revert it. Everything looks good. Commit and push. Okay. There we go. That was our failed from last time. And with making that change, we should see this kick off. And it should go back to green here. And there we go. Everything looks good. All right. So that was one of the other steps we were going to add in. So that was dealing more so with Python code. The next one that we want to look at is validating changes with Batfish. So Batfish is an open source network configuration analysis tool. It's kind of cool from the perspective of it allows you to look for mismatch BGP settings and OSPF misconfigurations, duplicate router IDs, a whole bunch of different types of configuration errors that would cause any issues on the devices. Now, Batfish is interesting because it actually doesn't go out and interact with the networking devices itself. What you do is you end up creating a folder structure where you put your network configurations in there, and Batfish is actually just pulling those and comparing the different configurations from the different devices to make sure that everything looks okay. So to run Batfish, it is super easy. Just these 4 lines. You can go ahead and drop those in. We can do that really quickly over here. If we can go Docker Batfish, Docker stop Batfish. That's what I meant. I knew I was missing a word. Docker remove Batfish. We can just copy this over. Docker PS to see what is actually running, and we can see that the Batfish container is actually good to go 5 seconds ago. And there we go, pretty straightforward as far as getting that running. Now, as far as your directory structure, you're going to take whatever network devices that you're going to be connecting to, and you're going to create a snapshots directory, and then within that, a configs folder. And within that, you're going to end up putting your network device configs. So if we actually go over here to my GitHub, we got snapshots within that configs, and then we have the actual network device configurations. Now, depending on how you want to get those configs in there, I mean, we're all about automation, so it'd be very easy to do some type of script to back them up, put them into a file somewhere, and have that pushed up to GitHub. For me, since I'm not actually doing this across a whole bunch of different devices, I'm just putting them into PyCharm and then pushing that up into the correct repo. So the big thing with Batfish, which is pretty cool, is they have all these different assertions. And the assertions is really what it's looking for to make sure it's working properly. So you can kind of see in the script that Julio put together, we're looking for duplicate router IDs, incompatible BGP sessions, incompatible OSPF sessions, unestablished BGP sessions, and no undefined references. You can kind of dig through. We're going to look at his Python script here in a second. But really, there's nothing with that script that you need to change, unless there's actually other assertions that you might be interested in adding. And you can actually go to the assertions helper page for Batfish to see what other things you can actually look at. Now, when it comes to actual changes that you're going to need to do within the script, network name, you're going to need to name that whatever you want. Snapshots and the snapshot directory, as long as you actually create that and put your stuff in there, you should be good. The host IP, though, is actually going to be the IP of your device that you're running all of this from. So in this case, it's my VM that's running Ubuntu that I'm using as my CICD pipeline server. Then I just have the IP address for that in there. And then Julio kind of goes through some different examples of what this looks like when there's different types of misconfigurations. So we can actually go back over to PyCharm, and we can take a look at the config first off. And that was the Batfish check. So don't really need to edit anything in there. He already has everything all defined. And here is the areas that you needed to edit. Really, I just changed the name and the IP address, and that was all I had to do. As I already mentioned, we already have the snapshots directory as well with the configs in there. So then when it comes time to actually implementing this into our pipeline, we're going to put it in the drone config. So again, pretty straightforward. I'm just going to copy this. All this is going to do, we give it a name, and then the image we're going to use, we're using our pre-built Docker image. Again, because that makes things so much quicker. And then the commands, all it's going to do is run a Python command to run the Python script. That's it. Very, very easy. So let's go and put that in our drone config. And remember, I said order of operations is important here. So we're going to go the Python check first, then the Batfish check, and then it's going to run our Python script, the NetMiko one that's reaching out and actually interacting with the network devices. Let's see if there was anything else. I think that was it. We can go ahead and commit and push that. All right, now we can go back, take a look at our drone server, and see if that pipeline kicked off. Testing initial build out with Batfish. All right, so pulled down all the necessary stuff from GitHub. The Python black code format check passed. Now it's doing the Batfish pre-checks. And we can kind of see what it's starting to go through here. And we'll see how long this takes since I did just spin up that Batfish instance and it hasn't done stuff before. It could take a little bit of time to do that. All right, so looking for duplicate router IDs. No duplicate router IDs. Testing for incompatible BGP sessions. That was fine. Testing for incompatible OSPF sessions. I think that might be like if it's a multicast on one interface and broadcast on the other. Testing for undefined resources, no undefined resources. And there we go, that was it with that. And then it moved on and it did the script there to look for the IP interfaces on the device. So that was good. I mean, it still took 1 minute and 30 seconds though. But like I said, I think that's because of the fact that it hadn't run yet, or the Batfish container hadn't run yet. So let's go and make a change. Let's do a duplicate router ID. And then you can see what that will look like when that fails. So we're just going to go into our snapshots, configs, text. We're just going to change this to 1.1.1.1 because on switch 1, that is what it should be. Yeah, 1.1.1.1. So we can go ahead and commit that. Testing Batfish with duplicate router ID. Commit and push. Testing initial build out with Batfish duplicate router ID. All right, so cloned it. Pulled the stuff down from GitHub. Black code format check. That was done. Nothing needed to be changed there. Batfish pre-checks. Let's see, last time this took almost 2 minutes. Let's see if this one goes a little bit quicker. Yeah, we're already into testing duplicate router IDs. So yeah, this is moving a bit quicker than the last one. Okay. And we see here that caught as a duplicate router ID on switch 1 and switch 2. They're both shows you what the IP address is, and at that point it kills the pipeline process because we got to go fix this before we do anything else. So that's great. Batfish is cool, but we're kind of limited just by whatever the assertions are that we can put into that configuration. There's other things that we might not be able to see that are misconfigurations that we'd want to take a look at. And that is actually what we're going to be looking at in the next video that we do, is looking at using NAPALM and Nornir to actually make direct connections to the device, do a dry run to actually see if the configurations that we're going to push are going to cause any issues, actually end up having that be automated through GitHub so that we end up having approval after the dry run for it to be good to actually be a real run and be pushed, whatever the configuration changes are that we want to do, and then use a tool like SUSIQ, which is actually going to be making real-time connections to be able to pull information after the fact to verify that everything is working correctly. So I think that's going to be about it for today. I appreciate everybody dropping in and checking this out. So just a quick recap. We actually started working on our drone YAML configuration. We got our first Python script to work. Took a bit of time though, because we actually were pulling down and building the container in real time. Took 30 minutes. We ended up deciding to build out our own container image that we could use and call anytime we wanted to do other things in pipeline. Once we did that, I mean, it brought it to like, what was it, 15 seconds, something like that. Really, really quick. Then we started looking at adding some other tasks or steps to our pipeline. So we did some Python formatting, and then we did some network configuration checks to make sure that there weren't any types of misconfigurations or duplicates, router IDs or BGP and OSPF misconfigurations with Batfish. So quite a bit. Our pipeline is coming along. It's pretty cool. I really enjoyed going through the process. Hope that you're enjoying watching me move through and show you how I went about building all of this out. As always, if you have any questions, throw those in the comment section. I'll hit those up. Looking forward to doing part 3 of the series. Hope that you're enjoying it. Go get at it. Have a great week, and we will talk soon. All right, bye.